Hello everyone, welcome again in Eng-Man YouTube channel. So today we will continue our learning on tNavigator, and in previous series of video we talk about assisted history matching, and we run 25 scenarios with variables that are used for history matching, and as you can see we already completed the computation, and you can see the elapsed time. So the model is quite small, and the history is, I think it's quite short. So that's why we can achieve a pretty quick calculation. Okay, so now we will review the result. Currently, we are under the calculations. We can go to project info first if you want to check, and calculations. Okay, and here we can click on this one, objective functions and results. All right, seems pretty interesting. So here, the legend here shows all the case that we have, and this is the result. The x-axis is the time, and the y-axis, currently we are looking at the oil total. You can also go to here, total, water total, liquid total, gas total, and so on and so forth. And also for the flow rate, oil rate, water rate, liquid rate. Okay. But for this case, we will be focusing on the oil total and water total. But maybe in some cases or in your own cases, you prefer looking at focusing on the rate rather than the total. Okay, so it's finally go back to you. All right, here we have several items, features to be reviewed here. The first one is objective function. So by the way, if we go back to graph, basically we can evaluate the mismatch of all the runs with the base case, the history case. We can review, we can assess, evaluate the mismatch using many variables. I can assess the quality of the matching based on oil total, or maybe based on water total only, or maybe based on oil rate only. Okay, you can use any single individual parameter to be used to assess the quality of the matching. But I think it will be better if we use, rather than individual parameter, but we will use combined parameter. So within the combined parameter, we include, we honor, we consider several parameters already. Okay, and that's what we will do. And first, go to oil total. So I will use oil total as well as water total. I will combine them, I will combine those two, and I will make a new parameter. I will call the new parameter as objective function. Okay, so using the objective function, this new parameter, I will assess the quality of the matching. Is the matching good enough or it's not? Okay, so I will create the objective function here. Okay, let me expand this one. So oil rate mismatch. Okay, so you have the table there. That table is important. And function type, we have history matching quadratic, history matching linear, history matching standard, forecast optimization, or custom. Currently, we are focusing on, or we are doing history matching. So we only focus on history matching quadratic, linear, or standard. Okay, to get more freedom to get the best match, I think I recommend you to use quadratic rather than linear or standard. Okay, so I will use quadratic, and here I only include currently one parameter, which is oil rate. But for this case, rather than using oil rate, I am more interested in using oil total and water total. So I just not focused on oil only, but I will also honor the water. Okay. So, yep. So here you go to field and choose under the parameter for the field oil total. And currently the deviation 0.05, deviation type relative, something like this. But I will use more parameters, and I will take on also from field, and it will be water total. Okay. And you can change the start date and end date. Okay. So maybe you want to focus on a certain parameter on a certain period of time, you can do that. But I want to first match the entire production history. So that's why I think I will use all the entire period of time. Okay, from 1967 to 1983. Okay, all right. I think it's good already. So this is our objective function. If you're interested, you can add even more parameters. But yeah, I think for the time being, let's start simple. So I'm I will just use two. Okay. And currently we are looking at oil total or water total and versus date, but we can also review this, show difference between historical and calculated values like this if you want. Okay. And you can also review the visualization setting if you want, and so on and so forth. Under this window, there are many features. So yeah, I think it's not possible to talk all the features. So I will leave it to you to learn it by yourself. Okay. We can also, what is this? Export table data to file, load history for bottom hole pressure, tubing head pressure. Okay. So for pressure, we will load history. So if you have your own data prepared already, you can load it into this interface. Okay. You can also take snapshot or even print. Okay, so that's for the objective function. Let's go to table. Okay, so here we have the this one, history value. Okay, this one, everything one, multiplier one, right? The original value, the actual case. And we also have V1, V2, V3. It's the run, the total run that we have, 25 cases. Okay. And yep. Okay, let's review field. We have field and we have wells. If you want to assess the quality of the matching using specific QLs, you can also review it using this. Okay. But yeah, we start with using field, the entire field. And then this is the current parameters. Okay. So currently we have variables and also field parameters like average pressure, oil rate, water rate, liquid rate. Of course, I'm interested in oil total, so I'm going to press this one. Oil total. There. Okay, oil total and water total. There. Okay, so what else we can do? We can also sort by pressing this. Okay. And here we have rates, total, okay, pressure analytics component. And we can also, okay, what is this? Move parameters. So as I said before, I'm interested in oil total and water total. So in the visualization, I want to drag these two columns from the most right to the most left. Okay. So I'm going to select this one, these two, I mean, and click on move parameters and then just drag them up. Can we? Yeah, like this. There you go. Okay. So now we are looking at the model and the field oil total and the field water total. Okay. So based on, for example, based on the oil total, let me press this one, sorry, the table. Okay. So the closest version, the closest run that will give me the run that will give me the closest value to my historical values is this one, run 21 and run 16. Okay, because my historical case is here. This is the value for oil total, but the oil total from run 21 and run 16, they are close to my base case, my actual case compared to other cases. Okay, of course, you can very possible for you to get other results. Okay, maybe your combination of values, minimum and minimum values are different with that I use with the thing that I use. So pretty possible that you will get other results. Okay, and if we use based on field total, just press this one and let's find our base case here. So the closest is 16 or run 8. Okay, so looking at the values in tabular form is also useful. Okay, so yep, that's for the table. And let's squeeze groups, wells, and all right, but I think I made a small mistake here. So here for the objective function, it is related to this one, the objective functions. So here by default, tNavigator already provide us with several possible objective function like oil rate mismatch, water rate mismatch, liquid rate mismatch, and you can see here. But let's say we want to create our original objective function. So I'm going to, I think here, delete it. Yes. And I want to, I think the original is well and oil rate, or maybe it's group. Sorry. Yeah, like this, I think, and this one is oil rate. So this is for the original objective function of oil rate mismatch, and I don't want to use this. So rather than using the available objective functions, I want to add my own. So click on add here, and let's call it objective O function underscore history matching HM. All right. So here, this is my own objective function. Okay, so this is actually a new parameter. And let's set this objective function. I want to focus on first, yeah, history matching quadratic, and I want to use the first, the objective type or the object type is field, and the parameter is, as I said, oil total. But not only oil total, I will combine this oil total with water total field, and let's use water total. That the weight 1 and 1 each. Okay, so this is my new parameter. I call it objective function history matching. It will combine the oil total and water total. The difference, yeah, the difference of oil total and the water total. The difference between the results from each run to the actual value. Okay, so let's go back to table and let's squeeze this one. And here, let's find objective functions. You see, we have 1 tree objective functions. Open that tree and let's find our new parameter, objective function history matching. Okay, and currently in this table we don't have this parameter, so let's click on this one. So we have objective function history matching. This is our parameter of main interest. So let's move that parameter here. Click on this one and move it up. Okay, where is it? I can't see you. Are there? Yeah, you can also move it horizontally, but it's rather slow. So let's move it vertically instead, like this. So yep, I put it here. So I have the model, the objective function, oil total, and water total. So I'm just going to focus on the objective function because it's already consider all the oil total as well as the water total. So let's sort here. So you see, interestingly, the closest run that will give me the closest value, the closest mismatch value, considering oil total and water total is this one, run 2, and then run 20. Okay? So if you want to check, let's go to the graph here. Okay. And yep, let's expand the experiment here. And let's untick this one. And let's see. This is the case, the base case. I want to see, not this one. Okay. And not 0, 0, but 0, 2. Okay. So based on water total, I think it's quite good. Let's compare it with the second rank. I think it's 10. Let's check the graph. Okay, so okay. So 2 is better than 10. 2, of course, is better than 9. Oh, actually 8 is better, relatively speaking, for water total. Okay, so 8 is a contender. 7 not good. 6 quite good. 5 not. 4 not. 3 no. 1 no. Okay. So let's consider about oil total. So for oil total, interestingly, 8 is good. Okay, so let's untick everything. Let's see. 8 is very good. Water total is also very good. Okay. And let's check the table. But the objective function is not good. So let's tick everything. So where is the run 8? So for oil total, sorry, oil total, run 8 is quite close. For the water total, run 8 is also close, very close. But for objective function, okay. So let me go back to my objective function. Let's, maybe we made something wrong. Oil total and water total, okay. History matching, quadratic, okay. And okay, so yeah, this is something that's quite interesting. So yeah, let me show you. Let's go back, untick everything. We are currently looking at oil total, and actually we have the two base case, 8 and 16. All right. You can also maximize if you want to know. And let's see if we can change the color, or maybe later. So this is for 16. So 16 is better than 8 for oil. And for water, let's check 8 and let's check 16. Okay, so these two are the best. But if you take everything first, if you go to table somehow and you just like this, set this OFHM like this, somehow the rank of 8 is at the bottom, and 16 is also not good. Okay, but let's see if you use oil total, 8 is good, 16 is good, close to historical values. And also for the water, 8 and 16 are the closest runs to the historical values. So that's why you need to be careful if you use objective function. So let's review our objective function, and rather than using deviation type relative, I'm going to use absolute. So if you use absolute values, you cannot run away. Okay, you will get those two as the best. So let's try. Go back to table and sort the objective function, and there you go. You get 16, the first rank, and 8, the second rank. Okay, so I'm going to use this 16 and 8 as the best. So be careful if you use relative for the deviation, this thing can happen. But if you use absolute, just by the word, it's absolute, then it's absolute. If you're the best, then you're the best. Okay, in oil or in water or in both. All right, you can also go to histogram. You can change the bins, orientation, horizontal or vertical. You can show the values or the percentage. Okay, it's rather slow. You can also show CDF. Okay, currently we are looking at the oil total. Uncheck the CDF. Okay, we can also show parameters from groups or from wells. Okay, we are currently looking at oil total. It comes from groups, it comes from field. Under the total, we have oil total or water total. Okay, so what does it say? It says that, for example, I have several runs, and runs that will give me 600,000 as the water total is 11, the frequency. Okay, the percentage as percentage. Okay, so yeah, if you want to understand more, just read more about histogram, or you can also go to help and check the assisted history matching guide. And the cross plot, yeah, we are currently looking at the field, but let's say we change to objective function and expand this one and go to objective function. Let's see, we basically want our parameters to lay on this zero line. And you can see we have two, the closest, the best scenario, which is variant number 8, run number 8, and variant number 16. This is for objective function. You can also look at oil rate mismatch. Now for oil rate mismatch, we have contender. Run 2 is quite good. Okay, and run 8 and run 16 quite good. But water rate, everything not very good, but run 2 is good. Run 16 is good. All right. And but for oil total difference, here, somehow, after reviewing the oil total, run 2 is not very good. But run 8 and run 16, they are good. They're close to this zero line. You can do that for other, yeah, if you want to check the wells. If let's say your key well is producer 1 and you want to check the oil rate, yeah, like this. Now, because it's not about mismatch, it's about oil rate. So you want to be as close as to this 149 line. Okay, so that's it. You can also change or make trend creator. You can also show settings here. History highlighting, you can use crosshair, his horizontal line, and so on and so forth. I'm not going to review all. Okay. And the graph, our beloved graph, of course. Let's go to objective function and yeah. All right, interesting. So let's uncheck, untick them all, and let's see about run 8. It's like this. Okay. Earlier is good, but at this interval, it's not very good. 16. Okay, at late time, it becomes quite mismatched. Run 2 is quite good. Okay, so yeah, it gives you high objective function, which is not good. Okay, so yeah, and again, if you want to check for oil total, you can go to oil total like this. What about run 2? Run 2 is actually not quite good for oil total, or also for water total. Okay. You can also right click, comment, or rename. Okay. You can also change this. Click this one. You can also show legend or not. Okay, and select coloring mode. Okay. Based on experiment, we only have one experiment, which is experiment 1, Latin hypercube. The color is green. But if you want to do the coloring based on the variance, then you can also add more. Okay, like this, run, for example. Yeah, you can change it. All right. Even for experiment, you can add to custom if you want. You can change to red if you want. Okay. And you can also do this. What is show quantile graphs? You see the P10, P90, P50, right? Okay. And stack diagram, you can show the mismatch or absolute mode, vertical or horizontal. Okay. Resolve into objects or based on parameters. Okay. And mismatch mode, objects investment and the model. All right. Objective function, this one, objective function, this one, the smallest objective function, and also 16, right? Again, you can go to this one, show legend or not. And for this one, analysis. Okay, this is also very, very important. You can first show absolute values. Okay, these are the values from correlations. And you can use either Pearson, Spearman, or linear proxy. Okay, so if you're talking about Pearson, let me think about it. So for this Pareto chart, Pearson, first about the value, we want value as close to 1 as possible. Okay, so value of 1 or value close to 1, positive 1, it means that that parameters has strong positive impact, influence on the this one, the objective, oil total or gas total or water total. Again, let's add objective function. All right, click on add and let's move it up. Okay, so let's focus on this. So that's for the value. If the value is close to -1, then it has strong impact on that objective, but in negative way. Okay, and that's for the value. And for the Pearson, so Pearson, if Pearson value, Pearson correlation is close to 1, in addition to the strength of the correlation, it also tells you that there is a monotonical dependence between the variable and the parameter. Okay, this one is the variable and this one is the parameter of or the objective. So monotonical dependence. But for Spearman, sorry, so for Pearson, it's linear dependence. For Spearman, it's monotonical dependence. Okay, what we want is actually, if it is possible, it's monotonical and linear. Okay, so that will be very, very predictable. If you increase this variable, then the parameter will be increased in almost direct way, proportional way, in a linear way. If you multiply by 2, maybe the objective will be multiplied by 2 also, or maybe 4, 6, and so on and so forth. Linear dependence and monotonical dependence. Okay, but sometimes Pearson can close to 1, Spearman not as close. Okay, so that's basically for absolute values. This feature is very, very important, especially if you're really, really, really a quantitative guy. Okay, but you can also show values as histogram if you are more qualitative guy, and you can also use variable filter. So what this result says, basically changing permeability multiplier, especially in region 4, FIPNUM 4, will give you the biggest impact on the history matching, on the objective function. Okay, and the second rank is the curvature of the oil water relative permeability, and also multiplier, permeability multiplier on the region 1, and then the water oil contact. And as you can see, changing the permeability in region 2 doesn't give you, you know, objective function. Uh, it doesn't influence the objective function significantly. But be careful, you need more eyes. You need eye from oil total and gas total and water total. So actually changing the multiplier, the permeability in region 2 does influence your oil total significantly, but it almost have no effect on the water total. So that's why it gives you influence on objective function as only small. Okay. Again, you can also click Quantiles if you want to get the P10, P50, P90. Okay. Yeah, usually you're also interested in, you know, the fluid in place. You can go to FIPNUM, fluid in place, and then original oil in place, and plus. Of course, there will be change. There will be variety of fluid in place because we also adjust the water oil contact. Okay, and you can add more variable here if you want, or sorry, if you add, you can add more quantile, like for example P75. Okay, and quantile setting if you want, and build probability model. Okay, but I don't think we have time to talk about this. All right, what else? So yeah, you can exercise using this one and go back to Pareto chart. Yeah, to create tornado diagram, tornado experiment is required. Okay, currently we are only running the Latin hypercube proxy. Hopefully later on we can talk about proxy, and yeah, for the CDF, for oil total, water total, and so on and so forth, including the fluid in place. If you want original oil in place, you can get P90, P50, as well as the P10. Okay, the most pessimistic, most optimistic, and the best case. We go to the right, 2D. I think it's yeah, you can make it pretty much useful, but maybe not in this video. Okay, so yep. So after reviewing all this, I arrive at the conclusion that, as I said before, based on the objective function history matching, the run 16 is the best. Okay, run 16 is the best. And the most important value, or the most important variables, are, if I need to choose 4, then it's the multiplier for the region 4, and this is the curvature of the oil water relative permeability, and then permeability multiplier for region 1 and the water oil contact. Okay, so but maybe you are not quite satisfied. We can further improve the history matching by using optimization. But of course, we do not need to optimize the rest of the case, because at this point, you already know that the combination of the variables don't give you, a good matching. So rather than rerun or re-optimize, or rather than optimizing all those runs, I'm just going to focus on one run, which is run 16. Okay, so I can right click and create new experiment from selected variants. Okay, but yeah, I think we can talk about this later. And I think pretty much we have learned many things in this series of video. And I'm going to see you later when we talk about optimization to improve the quality of the matching of this current case that we have. Okay, so that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next tNavigator videos. Thank you.